In this final video, we're going to just summarise all the observations and tests we've carried out. So the first test was the test for ammonium ions. We add sodium hydroxide and test the gas with damp red litmus paper. The red litmus paper turns blue. And that was because the ammonium ions were reacting with the hydroxide ions to make ammonia gas and water. And those ammonium ions could be aqueous or they could actually be solid in this case. Then we tested for carbonate by adding an acid, so e.g. nitric, and we saw effervescence. And that was because the carbonate ions reacted with acid to create carbon dioxide, that was the effervescence, and water. Then we tested for magnesium ions with a hydroxide. We wanted a source of hydroxide and we got a white precipitate because the magnesium ions reacted with the hydroxide. Mg is 2+, so we'd need 2 hydroxides to make magnesium hydroxide, which was our white solid. We then tested for barium ions with something that contained sulfate ions, like sodium sulfate, and we saw insoluble barium sulfate, so a white precipitate. Because the barium ions are in solution, they react with the sulfate ions in solution to make insoluble barium sulfate. And then to test for sulfate ions, it's kind of the reverse. We're going to use barium ions as a source of, so barium chloride as a source of barium ions. We're going to get the same white precipitate. So we're going to have the same equation as above. Okay, then to test for chloride ions, we're going to use acidified, so we're going to add some acid first, silver nitrate solution. That acid, remember, removes the carbonates. And we will get a white precipitate of AgCl because the Ag plus ions from silver nitrate react with the chloride ions to give me silver chloride. And then we're going to do the same thing for bromide. But we're going to see a cream precipitate because Ag plus ions are going to react with Br minus ions to give the cream precipitate of AgBr. And we're going to do the same thing with iodide ions. And we're going to see a yellow precipitate because the Ag plus ions are going to react with the I minus ions to give AgI solid. And then our last one, if we want to test for hydroxide ions, kind of going back up to this magnesium one at the top and reversing it, we're going to add something like magnesium chloride. And we're going to see a white precipitate of sparingly soluble magnesium hydroxide. The magnesium ions are going to react with the hydroxide ions to make magnesium hydroxide precipitate. So remember, the first two were acid-base, but the last 1, 2, 3, 4, 5, 6, 7 are all precipitation. So positive and negative ions making a solid. State symbols quite important.